GM-NAA. In 1956, General Motors, in partnership with North American Aviation, created the first recognizable operating system for the IBM 704 mainframe. Before this breakthrough, computers did not have an overarching software layer to manage tasks, meaning they could only process a single job at a time. Computer technicians had to manually load punch cards, mount magnetic tapes, and set up physical switches for every single program, a tedious process that left incredibly expensive mainframes sitting completely idle for hours between runs. GM-NAA solved this massive efficiency bottleneck by introducing the concept of batch processing. This setup allowed technicians to group a large sequence of different programs into a single continuous batch on a magnetic tape, which the system would then execute one after another automatically without any human intervention. This setup radically reduced setup times, optimized processor utilization, and allowed large corporations and government agencies to run complex engineering computations overnight. However, this pioneering system still lacked any form of real-time interactivity, meaning programmers had no way to monitor their code while it ran. They simply had to hand over their physical cards to an operator, walk away, and wait hours or sometimes days just to receive a printout revealing that a minor typographical error had crashed the entire run instantly. Unix. Developed at Bell Labs in 1969 by visionary computer scientists Ken Thompson and Dennis Ritchie, Unix introduced a portable, modular architecture that fundamentally rewritten the rules of software engineering. Up to this point, operating systems were hard-coded in highly specific assembly languages tailored exclusively for the exact hardware they were built on, meaning that whenever a company upgraded its computer, the entire operating system and all its applications had to be completely rewritten from scratch at a massive financial cost. Unix solved this crippling hardware dependency by being rewritten in the newly invented C language, making it the world's first highly portable operating system that could be easily adapted to run on completely different computer architectures. Furthermore, Unix introduced a unified hierarchical file system with folders and subdirectories, along with a design philosophy centered on creating small, highly specialized programs that could chain together using pipes to solve incredibly complex tasks. This modular approach had a massive impact on university research centers and early internet nodes, as it allowed programmers to collaborate and share software tools like never before. Despite these massive structural triumphs, Unix remained strictly constrained to a complex command line interface that required users to memorize cryptic text commands, making it far too intimidating and difficult for the average consumer to use in daily life.
MS-DOS, released by Microsoft in 1981, the Microsoft Disk Operating System became the dominant software backbone of the historic personal computer revolution. As the 1970s transitioned into the 1980s, the newly emerging microcomputer market was completely fragmented, with dozens of different manufacturers building home computers that lacked any unified software standard, forcing developers to manually rewrite their applications for every single machine on the market. When IBM rushed to build its new 16-bit personal computer, Microsoft purchased a basic command line operating system clone, adapted it into MS-DOS, and licensed it to IBM while retaining the rights to sell it to other companies. MS-DOS solved the fragmentation crisis by acting as a universal translator between software applications and the rapidly evolving 16-bit hardware ecosystem, enabling businesses and home users to run incredibly powerful spreadsheets and databases across a massive wave of affordable IBM-compatible PC clones. Because of this, standard office environments around the world adopted the iconic monochrome C prompt screen, turning the personal computer into an essential tool for global commerce. However, MS-DOS was built on a fundamentally limited, archaic architecture that was strictly single-tasking, meaning a user had to completely close out of their word processor and return to the main text prompt before they could open a calculator or check a separate file directory. Mac System 1. Launched by Apple in 1984 alongside the groundbreaking original Macintosh computer, System 1 brought the graphical user interface out of research labs and straight into the mainstream consumer market. Before this release, operating a personal computer still required ordinary people to learn and type abstract textual commands, a steep learning curve that kept computers locked out of normal homes and creative workspaces. System 1 completely solved this accessibility barrier by replacing the traditional command line prompt with a highly intuitive visual desktop metaphor, featuring overlapping windows, graphical icons, drop-down menus, and a revolutionary pointing device known as the mouse. Daily computer users no longer had to memorize syntax because they could now simply point at an icon, click a button to open a file, or physically drag a document into a trash can icon to delete it, instantly opening up the world of computing to digital artists, desktop publishers, and students. This dramatic shift completely changed public expectations of how humans should interact with digital technology. However, despite its beautiful, approachable design, the system was severely bottlenecked by the original Macintosh hardware, which lacked a hard drive and had highly constrained random access memory, meaning it still could not support running more than one software application at the exact same time. Windows 95. Microsoft launched Windows 95 in August 1995 with an unprecedented global marketing campaign, fundamentally redefining the desktop computing experience for generations to come. Prior to this release, Microsoft's graphical offerings were merely clunky, unstable visual overlays running on top of the underlying MS-DOS environment, which frequently crashed and lagged far behind Apple's integrated user experience. Windows 95 solved these historical stability and usability issues by deeply merging the graphical interface with a brand new, robust 32-bit underlying architecture, introducing elements like the iconic Start button, the desktop taskbar, and advanced long file names that replaced the restrictive 8-character limit of the past. It also debuted plug-and-play technology, which automatically detected and configured newly connected hardware components like printers and modems, eliminating the nightmarish manual configuration processes that had plagued PC hobbyists for over a decade. This release coincided perfectly with the massive public explosion of the World Wide Web, embedding Internet Explorer directly into the system and bringing millions of families online for the first time. However, because Microsoft chose to retain legacy 16-bit DOS code deep within the system to ensure older business applications would still work, Windows 95 remained notoriously prone to system-wide crashes, frequently trapping users with the dreaded blue screen of death during heavy multitasking. Mac OS X. Apple introduced Mac OS X in 2001, completely abandoning their aging classic operating system architecture in favor of a rock-solid, ultra-modern foundation. By the late 1990s, the original Mac operating system had reached its structural limits, lacking protected memory and preemptive multitasking, which meant that if a single web browser or word processor crashed in the background, it would instantly take down the entire computer with it. Mac OS X solved this existential crisis by discarding decades of legacy code and rebuilding the platform on top of a Unix-based core architecture called Darwin. This monumental shift brought true industrial-grade stability, ensuring that if an individual program crashed, the operating system would isolate the failure and keep running smoothly without affecting any other active tasks. Alongside this bulletproof performance, it introduced the gorgeous Aqua user interface, featuring smooth animations, drop shadow windows, and the iconic desktop dock for quickly launching applications. This architecture laid the exact technical foundation for all of Apple's future hardware lines, from laptops to tablets. However, this radical structural shift created a major short-term limitation as it completely broke native compatibility with older software, forcing users and businesses to run a slow, clunky emulation layer to access their existing files and expensive legacy applications. iPhone OS 1. Apple unveiled iPhone OS 1 in 2007, kicking off the modern mobile computing revolution by successfully shrinking complex desktop principles down into a pocket-sized device.
Existing mobile operating systems, such as BlackBerry and Windows Mobile, relied heavily on tiny physical keyboards, plastic styluses, and highly cluttered drop-down text menus that were clearly shrunken-down copies of traditional desktop layouts. iPhone OS 1 solved these mobile usability frustrations by introducing a revolutionary user interface built from the ground up for multi-touch finger gestures, utilizing advanced capacitive screens to support intuitive actions like pinching to zoom into photos and kinetic scrolling through contact lists. It replaced the desktop file system metaphor with a clean, approachable grid of uniform icons designed to be tapped with a bare finger, instantly opening up the world of mobile web browsing, emailing, and media consumption, a genuinely delightful daily experience. This shift transformed the mobile phone from a simple communication tool into a powerful personal media center. Even so, this historic initial release was incredibly locked down and limited in scope, completely lacking a digital app store for third-party developers, while failing to include basic software features that consumers took for granted, such as copying and pasting text or running background applications. Android 1.0. Google released Android 1.0 in 2008 as a highly flexible, open-source alternative to Apple's tightly locked down and proprietary mobile ecosystem. Following the launch of the iPhone, competing hardware manufacturers and global telecom carriers desperately needed a way to compete in the touchscreen market, but they lacked the years of software development required to build a modern mobile operating system from scratch. Android 1.0 solved this massive industry challenge by providing a completely free, highly customizable platform built on top of the Linux kernel, allowing any company to modify the source code to fit their unique hardware buttons, screen sizes, and keyboard configurations. It introduced critical mobile UI innovations that Apple lacked, such as a centralized pull-down notification shade for managing alerts, customizable home screen widgets, and an open digital marketplace called the Android Market that allowed developers to publish apps without strict corporate approval. This open-source approach successfully democratized the smartphone, driving down hardware costs and putting mobile internet access into the hands of billions of people globally. Despite its rapid adoption, the early user interface was noticeably unpolished, stuttered during animations compared to the smooth iPhone experience, and the sheer variety of hardware instantly led to severe software fragmentation, leaving millions of users stuck on older versions without any clear path to security updates.